Hey kids, Flexing Teacher Weber here. I hope you're having a good day. So we're currently working on integers, and we have recently finished all of our work with fractions. But what I wanted to do now was, in some of our problem solving time, learn how to use all of what we've done with fractions to solve problems with fractions. So what we're going to do is we're going to be solving fraction problems where you have to identify the operation. Is it adding? Is it subtracting? Is it multiplying? Is it dividing? And the hard part is identifying what the operation is. So I've got some ideas here on how you can do that. So the first thing you want to do, and it sounds obvious, but really think about the situation. What's happening? Okay? Are you combining fractions together? Are you taking things away? Sometimes it's really obvious what's going on. Now, sometimes it isn't. So it's helpful to draw a picture. But if a picture isn't always the obvious way, you can also look for key situations or key words. So for adding, you'll look for words like total, sum, altogether, or combining, situations where you're combining fractions. For subtraction, you're going to look at for words like what's left and difference, because with subtraction, you're taking something away from something. Multiplication, you're going to look for groups of things. You're going to look for of. We'll talk about that in a second. You're going to look for the word times or product. Now, multiplication with fractions is the overlap of two fractions. So often you'll see one fraction of another. Dividing, you'll look for words like into or shared, breaking apart, quotient, or specifically with fractions, how much of one fraction is in another. So that's what you look for to identify which operation to use. Let's practice a couple of these now. Number 1, it says, one serving is 1/8 of a tray of Rice Krispie cake. How many servings are in 4 trays? Well, how many servings are in 4 trays? How much of something is in another? I'm thinking that situation might lend itself to dividing, but I also think, too, I can maybe draw out what this looks like. So I'm going to draw 4 trays of Rice Krispie cake. I'll use rectangles to draw those 4 trays. And I'll cut them into 8 parts, because it says one serving is 1/8. So I'll go half, quarter, quarter, eighth, 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 half, quarter, quarter, eighth, 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 half, quarter, quarter, eighth, 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 half, quarter, quarter, eighth, 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 eighth. And I will shade in 1/8. And how many 1/8s are in 4 trays? Well, I could count, or I might recognize here that I have 4 trays times 8 servings per tray. And so 8 times 4 is 32 servings. So this was a multiplication question, a multiplication of whole numbers. But I can see it as a division question as well. You could have done this. Okay, you have 4 trays. How many 1/8s are in 4? 4 divided by 1/8. And here's the relationship between multiplication and division, right? I would solve this by multiplying by the reciprocal or keep, change, flip. And then you essentially get the 4 times 8, right? 4 times 8 is 32 over 1, which is equal to 32 servings. Either way you slice it up, you still get the same answer. Let's look at another one. I drank 1 2/3 liters of beep from a 4-liter jug. How much is left? Okay, think about the situation. You're taking something away. And there's that key word there, how much is left? That tells us this is subtracting. You're taking away 1 2/3 liters from 4. Then you just have to think back to how to do this. Well, you need to have a fraction to take 2/3 away from. So I'm going to borrow 1 whole from the 4, make it 3. And I'll make that 1 whole over here as a fraction 3 over 3. And now I can just subtract. 3 minus 1 is 2. And then 3 over 3 minus 2 over 3 is 1/3. So how much beep is left? And beep, by the way, is a juice I used to drink at my grandma's. It's the most wonderful stuff in the world, but they don't make it anymore. So there are 2 1/3 liters of beep left. Okay, let's look at another one. If I fill my empty gas tank up with 1/3 regular gas, 1/8 mid-grade gas, and 1/2 with supreme gas, will my tank overflow? First question should be, why would I do this? Okay, so what we want to do, first of all, is think about the situation. I'm combining a bunch of gases in my tank. Combining, that's adding, right? So let's add up these fractions. So we're going to add up 1/3, 1/8, and 1/2. And if they go over 1 whole, then we're going to have to clean gas off the ground. We need a common denominator. We can get that by skip counting with the denominators. And when you do that, you get a common denominator of 24. Make your equivalent fractions. 3 times 8. 1 times 8. 8 times 3. 1 times 3. 2 times 12. 1 times 12. And when I add those up, I get 23 over 24. Whew! Lucky. I filled my tank up. It didn't overflow because it's below 1 whole. I should make that clear in the answer. I should say 23 over 24 is less than 1 whole. So my tank will not overflow. All right, let's look at one more. 3/5 of a school class is made up of girls. 1/3 of the girls walk to school. So 3/5 of a school class is made up of girls, and 1/3 of those girls walk to school. Listen to what I said. 1/3 of those girls walk to school. So 1/3 of those 3/5 walk to school. What fraction of the class is made up of girls who walk to school? Well, 1/3 of 3/5 is girls who walk to school. Picking up that key word there, that 1/3 of 3/5 tells us this is overlap, and overlap is fraction multiplication. 1/3 times 3/5. With multiplication, we can simplify our diagonals, and we get an answer of 1 times 1 and 1 times 5 is 1/5. What fraction of the class is made up of girls who walk to school? 1/5 of the class is girls who walk to school. Right? Fraction multiplication can be tricky to find in a problem. It's hard to tell if it's subtraction or multiplication. Okay. Last one. Natasha had 3/4 of a pizza in her fridge. She ate half of what was remaining. She ate half of 3/4 of a pizza. She ate half of 3/4 of a pizza. She ate half of 3/4. How much of the whole pizza did she eat? She ate half of 3/4. And half of 3/4 indicates fraction multiplication. No simplifying to do, so that works out to 1 times 3 and 2 times 4, which is 3/8. How much of the whole pizza did she eat? She ate 3/8 of the whole pizza. Okay, last one. How much of the whole pizza is left? Well, left means subtraction. Now think about what just happened here. She started off with 3/4 of a pizza, and she ate 3/8 of the pizza. So she took away 3/8. So she started with 3/4 and took away 3/8. That's subtraction. Need a common denominator. 4 times 2 is 8. 3 times 2 is 6/8. And that's going to be minus 3/8. Gives us 3/8. So she ate 3/8 of the pizza. That's how much she ate. And then there's 3/8 left. It's just a coincidence. So there is 3/8 of the pizza left. If you think about it, she ate 3/8. There's 3/8 left. That means that that's 6/8, and that's what we started out with in the problem, was 3/4, right? So beforehand, they had eaten 1/4 of the pizza. Hope that helps with your fraction problems. I have a bunch for you to try now. Make sure you refer back to this video and the notes as well. That's all for now. Flexing Teacher Weber, out.